Welcome, everyone. I will try to be as helpful as I can, even to complete beginners. This talk will cover the family of operating systems commonly known as Linux. To start, we'll cover how to get it, followed by how to run it once you have a copy. Then we'll look at how to run apps and generally interact with the system. We'll finish with examples of what you can do and some rationale, why you might want to try this at all. You might have noticed that I said a family of operating systems. To explain, I'll introduce a new term. A kernel is the software that coordinates all resource and device usage on the system. Here it is the kernel which bears the name Linux. We'll need more than just main memory bookkeeping and task management to make a computer useful, of course. This is where distributions come in. A distribution, commonly abbreviated distro, is a complete package made up of Linux itself and a selection of supporting software. Most distros are derived or forked from older distributions, and there are several old family trees recognizable to many Linux users. The part that you can see and which gives apps a particular look, if I minimize it, you can see my desktop. Is known as a desktop environment. These environments aren't generally married to a given distro. Some distros come with a selection of several, and you can pick one during installation. I'm not going to go over too many specific distributions because there are way too many out there to really cover in any detail. But there are a couple with which I have personal experience, and so I'll give you a little bit of background on each. Ubuntu by Canonical, based on the much older Debian distribution. It is a very well established and supported system. Canonical has done an excellent job of building a beginner-friendly community around their products. Its only drawback, I would say, is the rather conservative update policy. You may find that the software you need is a bit out of date in their official repositories. Another one is Antergos, based on the older Arch Linux distribution. It's running on this very laptop. Nearly the opposite of Ubuntu in update policy, they only test new versions of their software for about a week or so before making them available in the official update tool. I find it very pleasant and usable. I haven't had any problems with instability yet. So, there aren't a lot of really big like lists or comparisons of distributions online, but one good resource is, of course, Wikipedia's page on Linux distributions. They have a fairly nice table showing some of the major lineages, the family trees that I mentioned earlier, and a rough overview of like what kind of development model each uses. Also, one good site, if you can get past the rather old-fashioned layout, is DistroWatch. Oh, am I doing that wrong? I'm doing that wrong. Yeah, as you can see, very early Web 2.0 look. But it has a wealth of information on hundreds of distributions. Just remember to restrict your search specifically to Linux and distributions that are actively maintained. They cover a lot more than just those topics. So, assuming that we've chosen a distribution that we think we'll like, and we found the download page on the official website, you'll find that it comes in the form of a file with the .iso extension. This file is, in fact, a complete copy of the disk contents for a working installation of the operating system. And in order to use these, you will need to use an app that can really copy that can load the entire contents of that file verbatim directly into the bulk storage device that you intend to use to install the operating system. So one good way to do that nowadays is by USB thumb drives, because they have actually gotten incredibly fast and faster makes a smoother experience during the installation. So if I'm assuming that you're coming from Windows, I'm afraid, not too sure how you would do this on a Mac. But if you're coming from Windows, there is a lovely little tool. What did I just type in? I can't see what I'm typing in, I'm sorry. Nope. I think that's it. Yes, there it is. Rufus at rufus.ie. This tool is highly regarded as a means of loading the contents of an ISO directly onto a USB thumb drive in such a way that it will be bootable. In other words, even the computer's BIOS will know how to find the right piece of data to load as the operating system directly from that thumb drive when it's starting up. So you'll download the ISO and open Rufus with your thumb drive plugged in, and that will allow you to create a bootable disk out of that thumb drive. Now, there are a couple of other options if you want to try sort of dipping your toes into the Linux waters without committing to a regular installation. Unfortunately, I don't have a lot of experience with any of those. For example, virtual machines and hypervisors are a means of kind of splitting up your computer's resources in such a way that the operating system you want to use thinks it has the entire computer to itself. And they're pretty powerful tools, but unfortunately, I really don't know how they work, so I won't go into those. Also, there's the Linux Subsystem for Windows, which is a recent Microsoft technology produced in partnership with the aforementioned Canonical. And it is effectively a compatibility layer that lets you use a Windows 10 machine as though it had Linux kind of running inside it. You get a lot of the basic system tools that are available to you when you're using Linux on that. I don't have any personal experience with it. Some people have said that it works great, and others have said that they couldn't use it because the performance wasn't quite good enough. So mixed reviews, but more recently things seem to be getting better. Now, what you'll see when you run a boot disk, and actually you will probably just see the operating system itself. Let me see. I don't know if there's a good way for me to show directly the contents of my main desktop, because that would give you a pretty good idea of like what the rest of the interface looks like. Well, anyway, you'll see the OS itself when you have the if you have the boot disk plugged in while the computer is starting up. Most computers are able to simply find that there is an extra bootable disk plugged in, and will try loading from it. There may be a BIOS option that you need to change in order to force the boot order to pick up that USB drive instead of your main hard drive or solid state drive. We can try taking a look at some of that later, but in any case, once you do have it running, you don't actually have to go through with the installation because you're actually running a complete copy of the operating system. You'll have access to all of the tools that come with it by default, and a lot of the functionality is there. You can surf the web, you can write documents, although it's usually set up in such a way that none of the data you create while you're running it directly from the USB drive will stick around. It's all just kind of poofed because it's only being held in RAM, and when you turn off a computer, the RAM eventually just kind of leaks flat. So that's one way of at least getting some experience with how the interface works. And then if you do decide to go with the installation, most installers will offer you an interesting option referred to as dual booting. And what this does is it partitions up the computer's drive in such a way that Windows still exists there. And the bootloader, which is a little tiny piece of software that runs right when the system starts and then actually does the hard work of getting the kernel running across the entire system, the bootloader can actually be configured so that it can call out to Windows and get Windows running, or it can call out to Linux and get Linux running. But there are some caveats involved with that kind of setup because Windows was never envisioned cohabitating with any other operating system on a given computer. Microsoft did not care to add a feature like that, and so it never went in. And so there can be some problems. I had a dual booting system for a little while, way back in the past. We're talking about like 2010 or something maybe, and I accidentally messed it up, and we lost a bunch of data. So yeah, I've had misadventures with dual booting, and also I've heard reports that Windows 10's update system has a reputation for destroying other OS installations. Be careful. I have not actually seen that occur myself, but apparently it will try to fix a corrupt boot sector if it finds that there's another OS in its space, which to Windows is the entire system. So, all right. Assuming we have not hit any of those potholes, we have a running system. Now what? I would just like, may I try reconnecting my HDMI really quick? Okay. It gives me another option here if I do that. No, it didn't give me the option. Say what? Yes. Oh, man. I wish I had known that earlier. Manage and configure displays. Yep, there it is. All right. Yep, there it is. So let's see if that actually, if I can apply that, and we'll see if it does what it's supposed to do. There it is. Excellent. Okay. So from here, we can see that it's actually a lot like an ordinary Windows or Macintosh environment. And most of these desktop environments do have something very close to Windows Start menu. In this case, it's called the launcher, application launcher. And I can even hit the Windows key to bring it up. And it has an application submenu with all of my apps. And I can even begin typing into it to bring up a program, or to search for programs and bring them up. So you don't have to worry about, leaving behind too much muscle memory or knowledge if you're coming at this from Windows, at least. And then also, of course, there's a basic file manager with each of these things. The one on this desktop environment is called KDE, and it comes with a file manager called Dolphin, and that's just other than the dark theme, it's a lot like Windows Explorer. And you'll often see links to home and documents and similar directories, and those are almost exactly like what you'd expect to find in Windows or Mac. So at this point, you're probably thinking, so far everything I've seen is like Windows, but it's less feature rich, and why would I want to do that to myself? And so at this point, we'll talk about something that you might have had experience with if you've used the Ubuntu subsystem for Windows, and that is the shell. Shell is the command line, or there are several different shell apps, but each one is the command line interface that comes with every Linux distribution. And it's a little different. If you have any experience using the Windows command line or Windows command prompt application for anything, it's a little different than that. And the important thing to remember about it is that it's actually more like a programming environment than just a simple line-by-line invoker. So let's see. Oh, finding it. Of course, you'll need to find it first. Usually, you will just search for term or terminal in your application launcher. And for example, my regular terminal is called console, spelled with a K because this is the K desktop environment. And I have a couple of other sillier ones, but we'll stick with console for now. The shell isn't magic, but it does help you coordinate a lot of basic system tasks. You can use it to feed information through just about every corner of the system without much in the way of restriction. To demonstrate this, let's look at a couple of simple commands, and we'll get a feel for how it's intrinsically different from its counterpart on Windows. So let's start with, this is the ls command. Let me go ahead and zoom in a bunch so we can actually see this a bit better. There we go. I think that's visible. Yes, it's even visible on the little screen. Okay. And then we do, so this is ls, which is like the dir command in DOS and Windows. And then I pass in the command line arguments, capital A and lowercase l. And that will make a nice list of everything. Of course, I'm just in my home directory, so there's also a bunch of hidden stuff that, and it'll look kind of ugly. Let's go into my documents really quick. We're going to do that again. And there you see there are a few files and a few directories. Now, let's assume that instead of the 1, 2, 3, 4, 5, 6, 7 entries, I had 1,000. And a bunch of them are directories and a bunch of them are files. And I wanted to filter this list for just the subdirectories of the current directory. Well, one way I can do that, and this is hardly the only way, but it lets me show off a particular feature. So of course, what you're looking at, once I entered that command for the first time, it spooled out a bunch of text, and those lines of text ended up just being printed into the console here. But the nice thing is that text, I mean, it's basically treated as a string that's still inside of a programming environment. And you can kind of, in much the same way that in most programming languages, you can chain function calls together or nest method calls or something similar. In Shell, you can use a form of redirection. And that redirection is controlled with this operator, the pipe. It's the vertical bar, the thing above the backspace on your keyboard. And here, I'm going to pipe from the output of ls this list into a simple text searching application called grep. And grep takes a criterion in the form of a regular expression, and I won't go into that, but it's like a kind of super simple language that's meant for finding specific patterns in text. So in this case, what I'm telling grep to do is look for any lines that begin with the character D. And there we go. What it gave me, what it eventually output, it fed the output of as-al into the input of grep with the criterion caret D. And it gave me back all of the lines that began with the character D. So, so you can see how in a lot of cases you can actually envision almost all of the work done by various system utilities as a matter of passing a sequence of characters in and then pulling a sequence of characters back out, and then being able to use the pipe, or also, like, for example, the file redirect operator. Let's see if that worked. Yep. And so there we see on the, and this, the application I used there to open that text file was, it's called less, and it's what's known as a pager, which just means that it turns the console into a viewing, kind of a view window for a text file. Pretty simple stuff. You can see how, like that kind of changes the equation. You don't need a lot of, you don't need to do a lot of programming ahead of time. A lot of what you need to combine the functionalities of various applications is actually a part of the command line's own capabilities. So that's just one piece of what makes this entire experience at least somewhat different from what you're likely to encounter elsewhere. Now, that's mostly it for the main body of the presentation. So I'd like to talk a little bit about some reasons that you might be interested in doing this at all. It seems like kind of a hassle, so hopefully it'll sound a little more interesting. In one sense, a lot of things are just immediately open to you as soon as you start up this machine, because an immense variety of software is already part of it. Whereas most systems have an update utility, these machines, or these operating systems, are usually bundled with a system or an application known as a package manager. And a package manager is, you can think of it kind of like the App Store on your phone. But it's, the feel of it and the purpose of it is quite a bit different. Where an App Store is mostly geared around connecting customers with the developers of software or publishers of other media. A package manager is focused around presenting free software in such a way that you have a kind of like known good source for everything that you might need to use with your computer. Take a look at the graphical front end for the package manager on my system here. And we can see that I have a bunch of updates waiting for me. But that's hardly the end of the story. I mean, this thing contains thousands and thousands of applications and libraries. And it's actually drawing all of this content from a repository that, well, most of the big repositories are specific to a given distribution, but they tend to kind of break out into these constellations because there are a couple of competing package formats for software on free operating systems. They tend to sort of align with these old family trees that I mentioned earlier. In this case, since this is an Arch-based operating system, it uses the Pac-Man format, and it is, I'm trying to remember, I think, yeah, this is also, it's drawing from a view of the databases in the Arch repositories, and then also supplemented with the Arch user repositories, which is, oh, that's not what I was looking for. Yeah, it might be community. But in any case, there are, yeah, this just goes on and on. So, most of these repositories are community run and totally focused on maintaining a safe, free software environment. They tend to strongly prefer free and open source licensing for verifiability reasons. It helps everybody sort of know that they're getting what they intend to get and getting what they need. Now, as to, you know, like what you can do with these systems, well, since this is kind of like a learning to develop type group, I remember a time when you could barely find an academic paper on some computer science subject where the example, like if they had a worked example, they gave that example in terms of a little demonstration Linux program, and you needed, you know, like it was the build sequence was set up so that you were using tools that you only usually find on Linux instead of anything that you would find on Windows. These days, that's much less common. Enough, like really, I guess you could say kind of like open-ended low-level tools exist for Windows now that more of that kind of thing is becoming universal to just about everybody's machine. But there's still a lot of really interesting little experiments that go on exclusively in a Linux context. And then also, because in some senses, like, you know, since you're, you know, like there was a time when you couldn't buy like, you know, high-end software for Linux because nobody cared enough to make any. And so if you wanted to actually write new stuff for it, you had to rely on what you could find. And so people, especially there's a very old software project called the GNU project, and a lot of their stuff still forms the core of the low-level tools in most Linux distributions. And they, for example, produce the C compiler, which is integral to practically every Linux distribution out there. So as you can see, currently I have installed GCC version 8.2.1, and I think that is the latest update to GCC, because this is a pretty quickly updating platform. And then also, so yeah, GCC gives you right out of the box C, C++, Objective-C, Ada, Fortran. They used to have a Java thing built in. But anyway, there's that. And then practically, because it has become so vital to so many system administrators running or writing slightly more sophisticated scripts than what most people are comfortable doing in shell, Python has become an integral part. And of course, this thing is running Python 3.7.1, and so you can pretty much count on that being there out of the box when you install any modern Linux distribution. Do that. And then there are dozens of others. I mean, let's see, Common Lisp has a distribution for Linux. Digital Mars D. I think. The .NET family is available in the form of Mono, and that provides C#, F#, Visual Basic .NET, and if you don't mind doing a little bit of porting work, any of the other languages that run on the .NET environment. Haskell, for a long time, 64-bit builds of Haskell were only available on Mac OS and Linux. It wasn't until 2013 that they started having 64 builds for Windows as part of their main distribution. The Erlang family, Erlang and Elixir, those are usually available from the main package repository. Julia and GNU-R and GNU Octave for statistical and scientific computing. So, yeah, a huge variety of stuff. Setting up and tearing down a development environment is pretty straightforward because in a lot of cases, the whole paradigm is based around just creating a new directory and starting some text files in it, and then invoking the build tools on one of the text files in that directory. And only if you actually plan to install it system-wide does anything else touch any other part of the system. So if you're trying to get rid of a troublesome configuration in your development environment, usually it's as simple as just deleting the configuration file in that directory that you created. And that's all you have to do to get rid of that. Finally, I would like to talk a little bit about kind of the philosophical nature of why this entire environment is a little bit different than, and why the experience is a little bit different than what you might be accustomed to from an operating system that you need to purchase. You don't owe anybody anything from what you learn. Part of the Free Software Foundation's general public license, you're free to study the source code, modify the source code, redistribute the modified version, as long as you give credit where credit is due, and tell people how you've modified it. Then it's okay, and that actually holds for most components of these systems. Some of them do come with drivers that were provided by specific vendors under non-free licenses, but in most cases, those aren't completely necessary. And so you actually have a certain degree of tacit ownership over every piece of code running on the machine, from the thing that's switching between tasks so that your CPU cores are utilized correctly, to any application that you can find in most of the big repositories. You're allowed to do the same thing. You're allowed to break them apart, look at how they work, put them back together, try your own version of it, and it's not incumbent upon you to give back for anybody else's definition of giving back. It's entirely up to you how you want to contribute or not contribute. And most people are perfectly happy just knowing that you have benefited somehow from your use and your education from their software and from what they have experienced by writing it. And of course, there's just the multiplicative effect of knowing that not only can you learn from this piece of software, you can look at the software that supports it, that runs beneath it, and you know that the principles that the entire thing is built, that this entire edifice is built upon, are open to you. You are not prevented from, or rather you are not discouraged from at least trying to learn from any piece of this. So I hope this has not been too onerous a talk. Thank you so much for listening, everybody, and I would love to take any and all questions.